Hey guys, let's do another one, guys. This one's on contextual questions, AP review. So hopefully you enjoy it. Give it a thumbs up. I guess not right now. I guess at the end of the video, but I would appreciate it if you guys enjoy it. All right, let's get right into it. All of these are going to require a calculator, guys, because they always do, and they're really good questions too. I really enjoyed these. So let's do it in one take, and we make mistakes. We make mistakes. Let me know. And all right, for a second time, let's just get right into it. All right, it says here, question 1 from 2004 Form B, question number 2. T is between 0 and 31. The rate of change of the number of mosquitoes on tropical island at time t days is modeled by R of t, and this 5 square root of t cosine t over 5. This is in mosquitoes per day. So this is already a rate, guys. So R of t, and this says there are 1,000 mosquitoes on tropical island at time t equals 0. All right, show that the number of mosquitoes is increasing at t equals 6. So this is straightforward. Usually, how do you know in calculus when a function is increasing or decreasing? You take a derivative. But this R of t, this R of t is like a derivative because it's already a rate, if that makes sense. So I'm going to find out what R of 6 is. If it's positive, the number of mosquitoes is increasing at time t equals 6. If it's negative, the number of mosquitoes is decreasing at t equals 6. So I'm going to type this guy into y1 into my calculator. So here's my calculator, and I'm going to go y equals, I'm going to type 5 square root x, because I'm probably going to need this function again, and then cosine, and then I'm going to push the little fraction thing here. You probably don't need it because the argument is just x over 5. Let me delete that right there. Look at all those mistakes. So there it is, x over 5, close, done. All right, I'm going to go to my home screen. There's no need to take a derivative. I'm just going to say y1 of 6. You can also look at a table if you want. Alpha, calculate there, and you'll get the y values there. y1, open parenthesis, put the number 6 in there, close it, enter. And there it is. I lost it. Let me make sure that my mode is in radian. Yeah, it is. 4.437 or 438. 437. And I'm going to say, I'm going to write it right here. Number of mosquitoes. That's a U, guys. Number of mosquitoes is increasing at t equals 6 since R of 6 is positive. And there it is, guys. You're done with that one. Let's go to the next one. At time t equals 6, the number of mosquitoes At time t equals 6, is the number of mosquitoes increasing at an increasing rate or the number of mosquitoes increasing at a decreasing rate? Give a reason for your answer. So what they want to know is, if I have number of mosquitoes here and time here, they want to know, do I look like this graph or do I look like this graph? So what can you tell? Well, concavity, right? Concave up, concave down. So usually when I'm finding concavity of a function, it's a second derivative. But remember, R of t, this is like first derivative. Like, quote unquote, first der. If you're talking about, this is the number of mosquitoes. So number of mosquitoes, this is the rate of change of mosquitoes per day. So I need to take another derivative, or I guess the derivative of RT. So I'm going to take the derivative, and I'm going to find what R prime of 6 is. This is like a quote unquote second derivative compared to the number of mosquitoes. And I'm going to see if it's positive or negative. So let me take my calculator out again, and I'm going to push math, and I'm going to scroll down until I see der, which stands for derivative. Oh, I did it too much. It's a little laggy, guys. Derivative, there we go. Push X. I'm going to push alpha, trace Y1, and I'm going to put it at X equals 6. I'm going to push enter, and there it is. I get negative 1.913. Negative 1.913. And then I'm going to say, so I'm increasing at a decreasing rate since R prime of 6 is negative. So I'm going to write number of mosquitoes number of mosquitoes is increasing. It's increasing because R6 is positive, but it's increasing at a decreasing rate. So it looks like this one is increasing at a decreasing rate at t equals 6, since r prime of 6 is negative. And there it is, guys. All right, let's go to the next one. According to the model, how many mosquitoes will be on the island at t equals 31? Round your answer to the nearest whole number. Okay, this one is straightforward. All you're doing, guys, is adding up the number of mosquitoes. So 1,000 plus, look, this is in time between, this time is in days, between 0 and 31 of R of t. Mosquitoes per day times day gives you mosquitoes, guys. So I'm going to put number of mosquitoes equals 1,000. That's the initial amount, guys. Initial. Plus integral from 0. Well, I guess for my equation, number of mosquitoes is just 0 to t of R of t. And I guess if you don't like t, you can put an x here. It doesn't really matter. There it is. So there it is. This is my initial amount, and this tells me how many mosquitoes are going to grow. I want to know the number of mosquitoes at 31. So I'm just going to say m for mosquitoes at 31 equals, so I'm going to say that all this is just m of t. Mosquitoes at 31 is 1,000 plus integral 0. How did I get there? 0 to 31 of r of t dt, which equals, so I'm going to get my calculator again, and I'm going to type that in, guys. 1,000 plus, I'm going to go math, and I'm going to go down until I see the integral one. There we go, enter. And I'm going to go 0 all the way to 31. And I'm going to put alpha trace y1 and x, enter. Come on, buddy. There it is, 964.335. 964.335. And this is round your answer to the nearest whole number. So I'm going to say at t equals 31, there are 964 mosquitoes. There it is, guys. All right, let's go to the next one. To the nearest whole number, what is the maximum number of mosquitoes between 0 and 31? Show the analysis that leads to your conclusion. All right, this looks like a perfect form for a candidates test, guys. So I need to get critical numbers. So to get a critical number, I'm going to find where R of t is 0. And obviously, since it wants a maximum, you can just look where it's going from positive to negative, and you don't have to check your negative to positive. So I'm going to find my critical numbers first. Find critical numbers. All right, so that is where R of t equals 0. So here it is in my calculator. I already have y equals 5 squared root of x cosine t over 5. So I'm going to go to I'm going to go to window. I'm going to go 0 for x min and then 31 for x max. I just care about where do I go from positive to negative. So I'm going to try and hover around the x-axis. I'm going to go negative 5 to 5 because I know R of 6 is 4.43. So that should give me some good values there. Boom, I see 1 right there. 2, but I'm not going to check that one. And I already know what it is this one. So I'm going to find both of those. I'm going to state them, but I'm not going to look for the number of mosquitoes there because I know that one's a minimum. So let's find out. Where does this happen, this situation? That happens, so here's my setup. This is your setup, and I'm just going to say, where did that happen? That happens at t equals, I'm going to go second, calculate, I'm going to put number 2, 0. And then so left bound. I wish I probably should have counted there, right? Okay, there's my little guy. I'll go left bound, enter, right bound, enter, enter. So I get 7.8539. So 7.8539. I'm going to store that to A. And then T equals, so before I continue, guys, I'm going to store that to A. I hope I'm not complicating things here. I'm going to go X, enter, and there's that value. Store alpha A. So there it is. It's stored in A. And I'm going to find the other one, guys. I'm not going to use it to calculate anything, but I'm going to find the other one. Second calculate, number 2, 0, left bound. No, scroll to the right. Might be faster if you just type in the numbers, right? There you are. So enter, and then past that, enter. And by I mean by typing the numbers, count the number of scales. 23.561, I guess 2. 23.561. Let me write some more digits. 194. Oops. 194. 194. And I'm not going to bother storing that into anything because I know that's minimum. So here we go. I'm going to write time. So here's my candidates test. You test your endpoints and you test these guys. And I'm going to put number of mosquitoes. Number of mosquitoes. And I'm going to put the equation here, which is the top equation that I have there, which equals 1,000 plus integral 0 to t of r of t dt. All right, 0. At 0, I know I have 1,000. And then at 7.8539, maybe you put the letter A in there. I'm going to find out what that number is, and then I'm going to put 23.56194. 56194. I'm going to put NA for not applicable. This is a min. And then I'm going to put 31. And at 31, I know there were 964. So here we go, guys. So I'm going to calculate this one. I'm going to calculate this guy right here. So M of A is equal to 1,000 plus integral 0 to A of R of T dt. So come back to my little calculator. Home screen, 1,000 plus math 9. Now that I know what number that is, 0 to alpha A of R of T. That's in Y1. So alpha trace Y1, and then I push X down here, and I push enter, and I gotta wait, I guess. Come on, buddy. There we go. 1,039. 1,039. All right, to the nearest whole number. Perfect. So I'm just gonna say maximum mosquitoes occurs at 7.8539. Maximum mosquitoes 1,039 occurs at that time. So I'm going to put max mosquitoes of 1,039 occurs at t equals 7.8539. I didn't say anything false. Everything is perfect. There it is, guys. I think we're good. So we got the first one out of the way. Let's go to question number 2. This one, I believe I graded this one. I can't remember if I did. I'd have to go to my notes, which are somewhere. All right, so question 2007, question 2, calculator needed. All right, here we go, guys. The famous banana question. When a certain grocery store opens, it has 50 pounds. So 50 pounds of banana on display on a display table. Customers remove bananas from the display table at a rate modeled by. So this says remove. So this is out. Out, in and out, where F of T is measured in pounds per hour and T is the number of hours after the store opened. After the store has been open for 3 hours, the store employees add bananas, excuse me, 3 hours, guys, to the display table at a rate modeled by, so this is in. So this is how many bananas are being inserted. where G and T is measured in pounds per hour, and T is the number of hours after the store opened. All right, so out and in. We're probably going to need both of them. I'm going to type this one into Y1. I'm going to type this one into Y2, but do not use these letters Y1 and Y2 when you're doing the answers. They give you F and G, so use F and G. So here's my calculator, and I'm going to type those in. So second, memory 712 to reset everything, and Y1, and I'm going to go 10 plus, and I'm going to make it look exactly like that, guys. 0.8. I guess let me put the 0 in there if I said exactly, and then put an X in there, close that, put sign, and then alpha Y equals, enter, so you can get the little fraction, X cubed, so X to the power 3, X cubed over 100, and then close that up right there, and I'm going to push enter, and I'm going to type in the other one in Y2, 3 plus 2.4 ln, and then let's see, x squared plus 2x, x squared plus 2x. Close it, and I think we're good. All right, let's see. How many pounds of bananas are removed from the display table during the first 2 hours the store is open? All right, removed. So I want to know this, so I'm going to use this guy because that means removed, right? And it's in pounds per hour. So look at the area of that curve. Pounds per hour times hours is just pounds. So I'm going to write integral. So it says during the first 2 hours, so 0 to 2 of f of t dt. F of t is this expression. You can put the whole expression if you want, but since they already gave it to me that that's f of t, I'm going to write it like that. So I'm going to take my calculator out. I'm going to go, I have that in Y1, so I'm going to go math 9, 0 to 2, and I'm going to go alpha calc. Come on, buddy. There we go. Y1 and respect to x. Enter. 20 point, short-term memory, 051. 051. Did they say anything about units? Pounds. Done. All right. Find f prime of 7 using correct units. Explain the meaning of this. So f is a rate, and this is in pounds per hour. So think of this like velocity. And if I take the derivative of velocity, you get, that's right, acceleration. So my units are going to be pounds per hour. And all that just means is that the number of bananas being removed is decreasing at that rate in pounds per hour. So hopefully that made sense to you guys. It's just like velocity and acceleration. So here we go. I'm going to find f prime of 7 first. F prime of 7 equals, so I'm going to go math, and was it the 0 one? Nope, it was not. Math, I'm going to scroll down, and maybe it was the B. Can't remember. Oh. It's the number 8. All right, X, and then I'm going to push alpha, trace, come on, buddy, Y1 at 7, enter. And we get 8.119. So I'm going to write 8.119. 8.120 if you truncate it, guys. And this is going to be in pounds per hour. So there it is, and I'm going to write it like this. I'm going to write at t equals 7 hours, comma, the rate at which bananas are being removed is decreasing by 8.119 pounds per hour. If you want to write pounds per hour squared, that's fine. Or if you just want to spell it out, pounds per hour, it probably makes more sense. And there it is, guys. All right, let's keep going. Is the number of pounds of banana on the display table increasing or decreasing at t equals 5? Give the reason for your answer. Okay, straightforward. We just got to find out if f of 5 is bigger than g of 5 or if g of 5 is bigger than f of 5. So let's see how fast they're moving out. So I'm going to find what f of 5 is. F of 5 equals, and I'm going to find what g of 5 is. G of 5 equals. And whichever number is the bigger one is the one that's winning. And I don't want you to be a robot, guys. Think about it. If there's more bananas leaving, if there's more bananas going out than coming in, then the number of bananas is decreasing. If there's more bananas coming in than out, then there's more bananas. Those bananas are increasing then. So I hope I said that right. Did I say that right? If there's more out than in, it's decreasing. If there's more in than out, then it's increasing. So that's what I'm going to do, guys. So here we go. I know that on Y1 I have the F, so I'm going to go Y1 of 5. Push enter. So I get 13.795 or 796 if you round. 13.795. 13.795. All right, let's do G of 5. I have that on Y2. So alpha calculate Y2, and then that's at 5, and that's 11.532. 11.532. 11.532. Perfect. So I'm going to write since f of 5 is greater than g of 5, comma, number of pounds of bananas in the display table is decreasing. Number of pounds of bananas on the display table is decreasing at t equals 5. There it is, guys. Yay! This one is looking like it's kind of not that bad. It's pretty easy, it looks like, right? How many pounds of bananas are on the display table at t equals 8? Oh, simple. The amount they gave you plus how much was added, subtract how much was removed. So amount they gave you, so the amount that was initially, the amount that was initially there was 50 pounds. So I'm going to write 50 plus the amount that has been added. So added was G of t. We'll look at the units, the limits in a little bit. Plus minus the amount that has been removed. Minus integral of f of t. Okay, so I know that f of t is from 0 to 8 because it tells me that right here, customers remove bananas from the display table to rate model by from 0 all the way to 12. So they want to know at 8 hours. So this is 0 to 8. I don't think the G of t was 0 to 8 though, because they didn't start putting in bananas until 3 hours later, right? After the store has been open for 3 hours, so there it is, guys. So, okay. Store employees add bananas to the display table to rate model by. So there we go. So, oh well, I guess it's like right there also as well. And I noticed that I've been saying the word so a lot. I need to stop that. 3 to 8. All right, here we go, guys. So there it goes. 50 pounds, and then this is going to be how many was added between 3 and 8, and I'm going to subtract how much has been removed between 0 and 8. So let me take out this calculator here. 50 plus math 9, 3 to 8 of how much is inserted. So that's G of t. That's on my Y2. So Y2, enter. X. Come on, buddy. X. And I'm going to subtract. Yeah, you couldn't do this with one integral, guys, because of the limits. The limits are different. 0 to 8 of Y1. All right. I don't think I made any mistakes. There it is. How many pounds of bananas on the display table at t equals 8? They don't tell me to round, so 23.347 pounds. 23.347 pounds at t equals 8. Yep. All right. Let's go to another one, guys. One more. All right. So this is from 2015, question 1. The rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t is 20 sine t squared over 35 cubic feet per hour. So this is how much water is going in. T is measured in hours between 0 and 8. All right. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by, so this is how much is going out. So I'm going to type this into Y1. I'm going to type this one into Y2. There are 30 cubic feet, so this is my initial. There are 30 cubic feet of water at the pipe at time t equals 0. Perfect. All right, so let's do that before we do anything, guys. Second, memory 712. Everything's been reset now. Y equals, I'm going to type in those numbers. So I have 20 sine, and I'm going to push alpha y equals to get the little fraction thingy. I'll put x squared, and bottom I'll put 35, close it. And in the D2, I'm going to put negative 0.04 x to the third power, negative 0.04 x to the third power, plus 0.4 x squared, plus 0.96 x. All right, I think I got everything. Second quit. These are both rates, feet per hour, cubic feet per hour. How many cubic feet of rainwater flow into the pipe during the 8-hour time interval 0 to 8? Okay, pretty basic. I'm going to use R of T because that's how much water goes in. So that's what they want to know. It goes into. So I'm going to write integral 0 to 8 R of T. This is called my setup. And as long as I am correct with everything, we should be good. So there it is. I'm going to type it into my calculator. I'm going to go math 9, 0 to 8. And then in my notes here, it looks like I put R of T in Y1. So alpha trace Y1, push X, and there it is. So yay, good thing for writing little notes there. So I get 76.570. 76.570. And this is cubic feet. How many cubic feet of rainwater flow into the pipe during the 8-hour time of 0 to 8? All right, perfect. All right, is the amount of water in the pipe increasing or decreasing at t equals 3 hours? Give a reason for your answer. This is exactly like the mosquito question, guys. Was it the mosquito question or the banana? The banana question for how many going in, going out. So I'm going to type in R of 3. I'm going to find what R of 3 is. This is how much goes in. And I'm going to put D of 3. This is how much goes out. And whichever one is the bigger one is the one that wins. So if there's more water coming in than out, then the amount of water is increasing. If there's more water going out than in, then the amount of water is decreasing. I hope that made sense to you guys. So here's my rate. I already got my rate in here. So I'm going to go Y1. I'm going to put 3. And I'll push enter. So there it is. So this is how much is going in. Short-term memory. 5.086. 5.086 cubic feet per hour. Let's see at the other one. So alpha trace Y2 at 3. 5.4. Ooh, perfect 5.4. Excuse me. There's more water going out than in. So the amount of water in the pipe must be decreasing. So that's it. So I'm going to write since D of 3 is larger than R of 3, comma, the amount of water in the pipe is decreasing at t equals 3. The amount of water in the pipe is decreasing at time t equals 3. You could have just said at t equals 3, but I went ahead and did that. All right, let's keep going. Let's see. At what time between 0 and 8 is the amount of water in the pipe at a minimum? Justify your answer. Okay. So this looks like another candidates test, guys, just like we did the mosquitoes. So it looks like it wants to know the amount of water is the minimum. So let's put what the amount of water is first. So amount of water is equal to, how much was in the pipe initially? 50? 30. Right here. 30 cubic feet. So 30 plus integral from 0 to t. Now these are both happening at the same time, guys. This is between 0 and 8. That's between 0 and 8. So you're going to do the amount in minus the amount out. So I'm going to do r of t minus d of t. R of t minus d of t. This is your net rate. If you don't want to do one integral, you can do two. You can do 0 to t of r of x dx or r of t dt minus 0 to t of d of t. So there's the amount coming in, amount going out. So there's your net rate. So I'm going to get my critical numbers. So how do I get that? Well, if we take a derivative of this, you would just get r of t minus d of t and then set that equal to 0. So I want to find where my rate going in is the same going out. This is the same thing as saying r of t minus d of t equals 0. This might be the easier one, guys, because that's what we always do in Cal, right? So I'm going to create a new line, and I'm just going to write y1 minus y2, because I believe r is in my y1, yeah, and then d is in y2. So here we go. I'm going to go to my little calculator. I'm going to go to y equals. I'm going to turn off y1 and y2. So turn off y1. I'm going to turn off y2. And I'm going to come right here to y3, and I'm going to go alpha y1 minus the amount going in minus the amount going out, alpha y2. And these are both rates. Remember that, guys. So this y1 minus y2 is going to give me my net rate. And then if I push, I want to hover, let's see, between 0 and 8. 0 and 8. And since I want to hover around the x-axis, I'm going to go -4 to 4. Or maybe -3 to 3. We'll see. Yeah, I'm going to go a little closer, guys. I'm going to go a little closer. I'm going to go -2 to 2. We only have one critical number. Notice it is changing from negative to positive. So that must be a minimum. So at 0, that's a local max, I guess. And then at 8, it looks like that's a max. So I already said I was going to do candidates test, so that's what I'm going to do, guys. T, and then amount of H2O. And I'm going to go 0, and then I need to find that value there, right? So second calculate 0, left bound, right there, right bound, right there, guess no, 3.27165, t equals 3.27165. I'm going to store that to A. All right. So initially I have 30. And then I already said that's A, so I'm going to put A. Well, I'm going to put 3.27165, but 3.27165. Everyone should, if you put A in there, it should have worked as well. And then 8 down here. I already know where I am at 8, right? Didn't I find that? Oh, no, I didn't. I'm going to find that. Well, I don't need to, because that's a max. So I'm going to put NA. This is a max. So there it is. So it has to happen here. It must happen there. So how much water is there? What did they want? The amount of water at what time t? Oh, there it is. You found the time t. But let's put the number of water in there just for kicks, for your justification. 0 of 8, r of t minus d of t. You might be able to justify it, guys, if you say some words like this is the only time that your r of t minus d of t changes from negative to positive in the entire interval 0 to 8. That might be a good way to explain it as well. But I already committed with this here, so I'm going to continue it with that, guys. Let me go ahead and do that since I already committed to it. Second quit. 30 plus math 9 0. Oh, I never stored it. X, is it in there? Yay. Store alpha A and math 9 0. Look, I forgot the 30, huh? I'll put it right now. Alpha A of alpha trace y1 minus y2. It's going to be a negative number. Enter, add 30 to it, and there it is. So 27.9645. And maybe you want to show it at 8. It's going to be a number bigger than 30. Or a number bigger than 27.9645, that's for sure. No, it's going to be bigger than 30 because of the areas. All right, so there it is. What time is the amount of water in the pipe at a minimum? Will justify your answer. So min at t equals 3.27165. 3.27165. If you want to make a statement about how this is the only time RT minus DT changes from negative to positive on the entire interval 0 to 8, I think that would work as well, guys. So I think that would work as well. All right, here we go. The pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Okay. Write, but do not solve, an equation involving one or more integrals that give the time w when the pipe will begin to overflow. All right, I'm going to have to read that again. The pipe can hold 50 cubic feet of water before overflowing. Okay, so 50 is the magic number. For all values greater than 8, I still have the same rates on the pipe until the pipe begins to overflow. All right. Right, but do not solve an equation involving one or more integrals that is to give the time w. All right, so I'm going to replace t with a w when the pipe begins to overflow. So I'm looking at this equation right here, guys. So I'm going to write 30 plus integral. They want to solve for w. It says right here, time w. So I'm going to write 0 to w. And I'm going to write r of t minus d of t. And then I'm going to close that all up. And right, but do not solve an equation involving one or more integrals that gives the time w when the pipe begins to overflow. It doesn't overflow until I reach 50 cubic feet of water. And so this tells you how much water you have. I'm going to put 50 right there, and you're done. That's it. Yay. I'm really happy right now, guys. All right. I hope you guys enjoyed it. Please hook me up with a thumbs up. I would really appreciate it, guys. I guess if you didn't like it, you can give it a thumbs down, but I prefer a thumbs up if possible. All right, guys. I hope you guys are safe. I hope you guys are happy. I hope you guys are happy with your education. Give the activity a shot. See what we can do. And I'll talk to you guys later, guys. See you guys on Saturday when we do a mock exam. Bye.